Hi everyone, my name is Mehdi Razwan. I'm currently an applications engineer at Saratech. I've been here for about 2 years now, and I have a mechanical engineering background and a passion for stress. Today we'll be going over what's new in Femap 12 Part 2. For those that haven't seen Part 1, I really recommend you do so. It's been done by Dan Nato, who's a very experienced stress engineer. For today's agenda, we'll be going over geometry manipulation improvements, specifically Boolean commands, faster feature removal, surfaces between curves, and copy and unite commands. We'll also briefly go over the Femap 12 report generation, as well as some of the pre and post processing improvements that Femap 12 has made. So without further ado, let's go ahead and get started. So this is the new Femap 12 user interface. It's been rapidly changed, or it's been greatly changed compared to Femap 11. And in this first example, I'm going to go ahead and import some solid geometry. In this example, I'll be showing you guys some of the Boolean commands that are new in Femap 12 and how they can really assist in the speed at which you process or pre-process your stress geometry. At this point, I'm going to go ahead and show you guys that all of these individual solids are separate, and they do have some level of intersection. This smaller cylinder is just touching that solid rectangular solid, and the larger cylinder is intersecting this rectangle, as you can see here. Now, what I want to do is I want to subtract this cylinder out of this rectangle, and you can easily do that by going to Geometry, Solid, Remove. Femap will then ask for you to select the base solid, and then to choose the tool solid that you want to remove from. I'm going to go ahead and select that larger cylinder, and then press OK. And as you can see, it immediately deleted that section of the rectangle that was intersecting with the larger cylinder. Now, I've purposely put these two cylinders separate from each other because I'm going to go ahead and pattern these two solids in a row of 3 by 3. And this is one of the newer additions to Femap 12 that is very useful. If you go to Geometry, Copy Solid, and then select these two solids and press OK, it'll then give you a dialog box that will ask you in which directions that you want to move or pattern these two solids. You can also do move to location. You can orient and transform them between coordinate system or along vectors and between planes as well. At this point, it's also going to ask you the approach. I'm going to do pattern, and you also notice that the mesh and loads and constraints and connections regions area is grayed out. This is because I have no mesh, no loads, constraints, or connections and regions. But if you wanted to do this for mesh, this also applies. You can always copy the geometry and the mesh individually across different vectors or planes or coordinate systems, like I've mentioned, which is really useful. Anyway, moving on, I'm going to go ahead and go with a pattern approach and press OK. And at this point, it's going to ask me for the vectors along which I want to pattern. I'm going to unclick the direction 3 because I only need to pattern in 2 directions. I want to make sure that I'm patterning 3 in each pattern, and then I'm going to click on the along vector option here, which will then allow me to quickly choose the vector in which I want to move and pattern these two solids. It's going to ask me for a base and a tip, and I'm going to use the points method so I can easily select these corner points. And I'm going to do this point to this point, press OK, and you'll notice that it will automatically update the spacing as well based on the points that you've given it. But you can always go in here and change this manually if you needed to. I don't need to, so I'm going to move on to the next vector and do the same thing here, a long vector. Pick these 2 points and then press OK. And then go ahead and press OK. And you'll notice that as expected, now you have a pattern of 3 by 3. I've purposely separated these cylinders from the rectangular bottoms because I want to delete the center rows from this assembly. And I can do that by going to Delete, Geometry, Solid, and then make sure that you have Pick Front or another selection type that you're comfortable with, and then select these center cylinders, and then you can always highlight to make sure that you have the right ones and press OK. This will then delete the solids, and then you're left with the rectangles on the bottom that have the cutout from the larger cylinder and then the 4 posts. At this point, I want to go ahead and add them together, and you can easily do that by going to Geometry, Solid, Add. And I like to use the box tool here, but for all intents and purposes I probably could have used a Select All as well. And then go ahead and press OK, and you'll notice that Femap will automatically combine all that geometry together as shown, and it'll also combine all the relevant curves and delete the non-necessary curves from your solid now as well. And that concludes just the Boolean aspect of Femap 12. There's a lot of other aspects as well, so you can also use the add command for surfaces as well as curves, and that can be very useful just in prepping your geometry. So in this next example, I'll be showing you guys the sweeping function, which is also very useful, which involves surfaces. So let me go ahead and import that geometry now. And I'm also going to import the step file because these don't have the curves. This can also be very useful for someone that might be, let's say you're importing geometry that is across different forms of CAD geometry. Well, now with Femap's new additions regarding surfaces and solids, Femap has improved the way that it can infer which you have slivers. And so let's say you are migrating or importing data from different sources. That's no problem, because as long as you change the tolerance on these solids, Femap can quickly infer that these two are meant to be together, for example. Anyway, in this example, I'll be showing you guys a sweeping function, which is very useful. But first, I'm going to show you guys that I can then add surfaces that are intersecting and then add them together after the fact. I'm going to go ahead and go to Geometry, Surface, Revolve. I'm going to revolve this curve across, and you can tell that it's intersecting this surface here. Go ahead and press OK. I'm going to choose this as my axis of rotation, and then I'm going to rotate 45 degrees. And you can tell that it's intersecting, but no problem. Let's go ahead and sweep it across this curve here, just so we can get a solid. We can do that by going to Geometry, Solid, Sweep. Select these two surfaces. That's okay. And then it's going to ask me to choose the curves to sweep along. I'm going to choose these two. Press OK. Oh, my mistake. I might be hidden here. Let me just try that one more time. Oh, here we go. So it looks like visually I have them. I just, for whatever I had my geometry off. My mistake. At this point, you'll notice that these two bodies are actually separate, as shown. But I can go ahead and add them and combine them with no problem. So Geometry, Solid, Add, and go ahead and press OK. Go ahead and press yes to this one as well. and you notice that you'll get one entire solid body. I'm going to go ahead and hide these surfaces just so it's a lot easier to see. And there we go. We have our desired solid from a sweep. You can also do this with combined surfaces as well. So previously in Femap, it was very hard to sweep across a surface that was combined, but that is now a new feature in Femap 12. In my last example, I'll be showing you guys a sheet metal bracket that's very easy to manipulate using the new additional improvements that Femap 12 has to offer. In the example, you can see that this sheet metal is rather complicated. I guess first I'll show you guys the solid aspect, but I'll show you that it also carries over to surfaces as well. To do that, I'm going to keep this solid. I'm going to make a mid-surface of this. Use the automatic option, and then select the outside surfaces. Oh, my mistake. Just pick front so it's much easier. And let me quickly make this into a mid-surface. And I think I need to just do the outside here, on this side as well. And just click on the highlight just to make sure that I have all of them. Looks like I was missing that one, so let me click that one. And I think we're good. At this point, go ahead and press yes or OK. And then I can always use a ruler to choose the default geometry thickness. I know it's 0.1, but just for the purposes of showing you guys, I can always go to the ruler, do between points, measure from this one, press OK, to this one, press OK. You'll notice that it's 0.1. Then I can press OK. Notice that it automatically makes the mid surfaces as shown. Now at this point, maybe you find out just through testing that you don't need certain holes or brackets, or maybe you need more stiffness in certain areas, or you just have an idea of that. You can always go to Feature Removal Loops. And this now works for objects that are not just circles and washers. So I can always delete this one as well, and so on and so forth. I'm going to need those, so I'm just going to leave that there for now. But I just for the sake of showing you guys, I really wanted to do that. You can also now edit the geometry to create washers and pads that are unrelated to just loops. And you can do that by going to the options here. Let me just bring this down a little bit so it's much easier to see. By doing include non-circular loops and splitting solids. I guess we don't need to split a solid here. So I'm just going to show you guys that we can then create washers around objects that are no longer just circles, as shown. You can also do it for more complicated geometry like this, as well as pads. And I'm going to show you guys that you can do the same thing here with pads as well. So go ahead and press pad, and you can do that as well. Oh, in this example here, so the problem was that this is a little bit more complicated than just a circle, so you have to specify where the pad center is, just so Femap knows exactly where it is. But if I were to do this to an object like this, you can easily tell that it creates that pad. And you can also have a washer added to the pad. So you can have a washer and a pad, as shown. And that can be very useful just to speed up cleaning up your mesh, as you might imagine. I also mentioned that feature removal is much easier to do. Loops also and curves also apply now to just objects that have a closed surface or closed boundary, not just washers, and so that can be really useful when wanting to get rid of a series or a number of circles at once, right? And so I'm going to show you guys that as well. And voila. Now it can be, you can use that same tool with the box pick command. So let's say you have a large vast plate with a lot of holes that you need to get rid of very quickly, you can do that as well. And that's just covering the surface of some of the newer aspects of Femap 12 that you can play around with the meshing toolbox. I also mentioned that you can always copy these surfaces. I hadn't really shown that to you guys, so I'll just show that to you guys right here. I'm going to select this surface here, copy that across just because I want that here. Press OK. Move along vector. I'll just do one single copy. It's going to ask me for that vector. I'm going to go ahead and do smart pick, or snap, I'm sorry, and then pick that vector right here and press OK. And you can do the same thing, feature removal, by going to the meshing toolbox, removing these circles in the middle that I no longer need. And you notice that there was a bigger washer here, but the same hold true of feature removal regardless. Let's say I need to add a surface between here that is tangent with both curves. That's also something that's very possible now. If I go to geometry, surface, between curves, ruled between curves, I can then tell Femap that I want a ruled surface between these two curves, and I can also tell it that I want it to be tangent to the surface. It's going to ask me for a surface for it to be tangent to, as well as along a vector if that's something that you need. And just like that, just with a couple clicks, I was easily able to create a ruled surface between these two surfaces and these two curves. And so that is primarily what I plan to talk about in this example. And just before I end, I'm going to show you guys some of the report generation that Femap 12 has to offer now. Go ahead and press open. And going back to that same criteria plot that I worked on earlier today, you'll notice that there are, this is a criteria plot, and it has a lot of different aspects to it. So in this example, I'm showing you guys a von Mises stress of anything above 17,500 psi, and so that's why you can see these elements here. If I want to change the legend at any point or the direction, I can always pick and drag. Oh, my mistake. So just pick and drag, and then I can put it on the top if that's something I need to do. I can also change the post views and drag them to a different location. I can also quickly and easily get to changing the number of levels in my contour. And if I need to go into more specifics, I can always click on this tab button right here, which will pull up the view options for me to change the specific aspects of my contour or criteria legend. I can do the same thing and pull and drag the coordinate system button as well. And you'll notice that with all of these visual entities, you have that tab button that will automatically go to that visual or the view options or the relevant view option, so you can change that. If I want to make that bigger, I can easily do that by clicking on the tab button and so on. Another cool thing too is just by clicking on that, you can go ahead and do all of these different 90-degree orthogonal views. Anyway, I'm getting a little bit too carried away with the visual interface aspects, but if we go here to Tools, Report Generator, Femap will automatically make a report for me, and just by typing in the info I can make a easy Word document to pop up with just a few clicks. This is going to be very useful when doing a modal analysis, in which case you want to see all the different types of modes. One great option is being able to change the entities, and so maybe you're only interested in the top 15 modes, but you've analyzed 25, for example. You can always change the options of the output that you want. You can also change the way that the pictures are oriented on the report, as I'll show you guys in a little bit. And so if I go ahead and press create report, since I chose the select output set to include in report, it's now asking me for which options that I want to show. Maybe I want to really interested in translations and total force and the von Mises stress. For the plates in the C3 direction. Go ahead and press OK. At this point, Femap will try to create that report. And right now, Femap is just taking the pictures necessary for the report. And shortly, we should have a report which will be really useful for us all. Okay, and just like that, I have my report in a Word document. If I just scroll down, it'll automatically generate a table of contents. It'll give me all the different types of results that I asked for, as well as the information that I needed in that report, such as the amount of elements, where I got the geometry, how many nodes and elements I have, the material choice I chose, as well as the material properties, and the type of analysis that I ran. Let me just quickly run through this before I let you guys go. As you can see, it does go based on the views that you need or you wanted, and so it remembers where you put that coordinate system. Here's a results summary telling you the total, the output vector, as well as the max displacement based on the nodes. Shows you your legend as specified. I made the mistake here of keeping my elements white, so that probably wasn't the best decision, but that's something that you can always change at any point in the report prior to creating it. And yeah, so that is just the gist of the report generation. Custom templates are always something that can be done, but it takes a little bit more effort. And that concludes the agenda today. And just to revamp what we talked about today as far as Femap 12, we talked about cleaning up geometry and how you can save time with the new Femap meshing toolbar and some of the geometry improvements. And we briefly went over the report generation using Femap 12's automatic report generation. As always, if you guys need any questions or have any questions for me, feel free to send me an email or give us a call. Our next session is Rethinking Design with Generative Design and Convergent Modeling. That will include Todd Perella from Siemens. And that will be on Thursday, October 4th at 11 a.m. Pacific Standard Time. As always, Saratech has engineering services that can address your demands and really have advanced engineering capabilities. If you guys are also interested in additive manufacturing, we have some of the state-of-the-art 3D printing options such as Markforged and HP, and big rep machines at our disposal. So if you're really interested in using or buying one of these printers, feel free to contact us for that. And thank you guys for attending. Feel free to follow us on Twitter, like our Facebook page, follow us on our LinkedIn, and if you guys ever miss one of these videos, feel free to also go and check out our YouTube channel. That's a great place for information that you might want to go check out. And as always, we also have a blog, and on each of these social media outlets we'll always have the option of reaching out to us and going and seeing when the next CES session is. And with that, thank you guys for attending. Goodbye.